Good morning, students. Today we will discuss some examples based on developable surface. Yesterday we derived the necessary and sufficient condition for a Moong's surface to be developable, and that condition is R into T is equal to S square, where R is the second order partial derivative of z with respect to x and t is the second order partial derivative of z with respect to y, and s is curl to z by curl x curl y. So the first problem is determine if the surface xyz is equal to a cube is developable or not. Now from here we can find the value of z, which is given by a cube upon xy. This is of the form of Moong's surface. So we can use this condition to check whether the surface is developable or not. So let us find the values of r, s and t. To find r, let us find curl z by curl x. Its partial derivative with respect to x. A cube upon y is constant. The derivative of 1 upon x is minus 1 upon x square. Now again differentiating this with respect to x, minus a cube upon y is constant. Derivative of 1 upon x square will be minus 2 by x cube. So we get the value of r, which is 2a cube divided by x cube y. Now let us find curl z by curl y. Its partial derivative with respect to y. A cube upon x is constant. Derivative of 1 upon y is minus 1 upon y square. So we get the value of curl z by curl y, which is minus a cube upon xy square. Now let us find t. T means curl to z by curl y2. It means its partial derivative with respect to y. So from here a cube upon x, that is constant, and derivative of minus 1 upon y square, that will be 2 by y cube. So we get the value of t, which is given by 2a cube divided by xy cube. Now what is s? S is curl to z by curl x curl y. So its partial derivative with respect to y. Minus a cube upon x square is constant. Derivative of 1 by y will be minus 1 upon y square. So we get the value of s, which is given by a cube upon x square y square. Now let us find rt minus s square. R into t, r into t, that will be 4 a raised to the power 6 divided by x raised to the power 4 into y raised to the power 4 minus s square means square of this term, that will be a raised to the power 6 divided by x raised to the power 4 into y raised to the power 4. Subtracting these two terms, this value is 3 into a raised to the power 6 divided by x raised to the power 4 into y raised to the power 4. Now this in general is not equal to 0. So we can say that the surface is not developable. Now the next problem is prove that the surface x into y is equal to z minus c whole square is developable surface. Now from here we can find the value of z. So this can be written as z is equal to c plus under root of xy. Now this is again of the form of Moong's surface. So let us find the value of r, s and t. To find r, let us find p. P means curl z by curl x. Its partial derivative with respect to x. C is constant. Its derivative is 0. Under root y is also constant. The derivative of root x, that will be 1 upon 2 under root x. So the value of p is obtained. Now to find q. Q means curl z by curl y. its partial derivative with respect to y. Derivative of c is 0, root x will be constant, derivative of root y will be 1 upon 2 root y. So we have obtained the value of q. Now what is r? R means second order partial derivative of z with respect to x. It means its partial derivative with respect to x. Here under root y by 2 is constant and derivative of x raised to the power minus half. By doing the derivative, we get the value of r, which is minus 1 by 4 into y raised to the power half into x raised to the power minus 3 by 2. Now let us find s. S means curl to z by curl x curl y. It means its partial derivative with respect to y. So from here root x by 2 is constant, derivative of root y, that will be 1 upon 2 root y. So we get the value of s, which is given by 1 by 4 into x raised to the power minus half into y raised to the power minus half. Now what is t? T is second order partial derivative of z with respect to y. Its partial derivative with respect to y. So root x by 2 is constant and derivative of y raised to the power minus half. Doing the derivative, we get the value of t, which is minus 1 by 4 into x raised to the power half into y raised to the power minus 3 by 2. Now let us find r into t minus s square. R into t is x inverse y inverse divided by 16 and s square is also the same. So these two terms are cancelled out and we have shown that r into t minus s square is 0, and this proves that the surface is a developable surface. Now the next problem is to find the equation of developable surface when the edge of regression is given. So we are given the edge of regression given by x is equal to 60, y is equal to 3t, z is equal to 2t cube, and we are to find the equation of developable surface. Now let us find the tangent vector to the given curve. By definition, tangent vector is dr by dt. So differentiating the vector r, we get the derivative of 60 is 6, the derivative of 3t square is 60, the derivative of 2t cube, that is 6t square. So we have obtained the tangent vector to the given curve. Now by definition, what is developable? Developable is the surface generated by the tangent to the edge of regression. So the equation of developable is given by vector r is equal to r plus mu into dr by dt. This capital R, this is the position vector of the current point on the developable. Substituting the value of dr by dt, capital R and small r, the value of vector r, capital R, this is having the components capital X, capital Y, capital Z. Small vector r, this is having the components 60, 3t square, 2t cube. And dr by dt has the components which we have already obtained 6, 60, 60 square. So substituting all the values in the equation of developable. Now from here we can shift this term on the left side. So this will become x minus 60, y minus 3t square, z minus 2t cube is equal to this term. Now from here we can find the value of 6 mu from all the three terms. So from this term the value of 6 mu is x minus 60. From second term the value of 6 mu is y minus 3t square divided by t. From the third term the value of 6 mu is z minus 2t cube divided by t square. Now from these equations we have xt minus y is equal to 3t square by taking these two members, and by taking the other two members we get the equation yt minus z is equal to t cube. Now we have to eliminate t from these equations. So multiplying this by t and this by 3, these two terms will become 3t cube. So 3t cube is equal to xt minus y into t, and this is further is equal to 3 into yt minus z. So simplifying this, we get a quadratic equation in t which is given by xt square minus 4ty plus 3z is equal to 0. Now again the equation second, that is also quadratic in t, and that can be written as 3t square minus xt plus y is equal to 0. Now we can solve these two equations by cross multiplication. We get t square upon minus 4y square plus 3zx is equal to t upon minus xy plus 9z is equal to 1 upon minus x square plus 12y. So from here, eliminating t, we get the equation of developable surface. Now let us see one more problem based on the equation of developable surface. So the problem is, find the equation of developable surface which passes through the two curves given by, the first curve is z is equal to 0, y square is equal to 4ax, which is the equation of parabola, and the second curve is x is equal to 0 and y square is equal to 4bz. Now by definition, the developable is the envelope of single parameter family of planes. So let us form a single parameter family of planes. So we have to find the equation of tangent plane. So firstly let us find the equation of tangent to this parabola. Now y square is equal to 4ax, this is the equation of parabola. If we are to find the equation of tangent, from here we can change y square into y by 1 and 2x into x plus x1, where x1 y1 is the point where we are obtaining the equation of tangent. So in the standard form, the equation of tangent to the parabola can be written as y is equal to mx plus a by m. Now we can form the equation of any plane touching this parabola by using these two equations. So shifting this term to left side, this will become y minus mx minus a by m is equal to 0. So combining these two equations with the help of a parameter lambda, so the equation of tangent plane touching the parabola y square is equal to 4ax is given by y minus mx minus a by m plus lambda z is equal to 0. Now because this touches this parabola, taking x is equal to 0 here and getting the value of y, which will be a by m minus lambda by z. So minus lambda z, a by m minus lambda z, we can put this value of y in this equation. So this equation will become minus lambda z plus a upon m whole square minus 4bz is equal to 0. Now by using the condition of tangency, because this equation 1 touch this parabola, so this quadratic equation will have two same roots, and for the same roots the discriminant of this equation, that will be 0. So we find the discriminant of this equation. This is a, this term is b, this is c. Discriminant is given by b square minus 4ac is equal to 0. Substituting the values of a, b and c and simplifying, we get the value of lambda, which is minus bm upon a. Now if we substitute the value of lambda in this equation will become y minus mx minus a by m, the value of lambda is minus bm upon a into z is equal to 0. So we have obtained the one parameter family of planes. Now by definition, what is developable? dwellable surface is the envelope of single parameter family of planes. So we can find the envelope corresponding to this one parameter family. Here M is the parameter. So by definition of envelope is given by the two equations. The first equation Fm is equal to 0, and second by doing the partial derivative of this with respect to M and equating to 0 means f dash m is equal to 0. Now from here, what is f dash m? Derivative of y will be 0. The derivative of minus mx, that is minus x. The derivative of 1 by m is minus 1 by m square. Here the derivative of m is 1. So we get this equation. Now from this equation, in this expression we take m common from this part. So equation can be written as y minus m into x plus a upon m square plus b upon a into z is equal to 0. Now using this term here, this will finally become y minus m into 2a upon m square is equal to 0. From here we get the value of m, which is given by 2a upon y. So putting this value in this equation, we get the equation of dwellable. Now let us see one more example based on the equation of dwellable. An ellipsoid having the equation x square upon a square plus y square upon b square plus z square upon c square is equal to 1. This ellipsoid is surrounded by a luminous ring. X is equal to 0, y square plus z square is equal to a square. Show that the boundary of the shadow casts on the plane z is equal to 0 is given by this equation x square upon a square plus y square upon b square minus c square is equal to a square upon a square minus c square. So in this problem, we are to find the equation of dwellable which touch this ellipsoid and this luminous ring. Now, by definition, dwellable is the envelope of single parameter family of planes. So firstly, we will form one parameter family of planes. So let us take the equation of plane which touch the ellipsoid and the given ring. So in general, we can take the equation of plane in this form Lx plus my plus nz is equal to 1. Because this touch this ellipsoid, so we can use the condition of tangency, and also this plane touch this ring also, so we can use condition of tangency. These conditions you have already learned in the paper of solid geometry. So if you are interested, you can read this topic from there. This is the condition of tangency for this plane to touch this conicoid. Clear? So the equation is a square L square plus b square m square plus c square n square is equal to 1. This is a condition of tangency for this plane to touch this ellipsoid. In the same way, for the luminous ring, we have a square into m square plus n square is equal to 1. Now let us eliminate n square from these two equations. Multiplying this equation by a square and this equation by c square and subtracting the two equations, we get this equation. Now, because we are given the plane z is equal to 0, so this plane intersects the plane z is equal to 0 in the curve given by Lx plus my is equal to 1. Now, we are to find the envelope of this subject to this condition. So by definition of envelope is the, by definition, dwellable is the envelope of single parameter family of planes. So if we consider the parameter L and taking with respect to this condition, so let us do the derivatives with respect to L, differentiating this equation with respect to L. So derivative of Lx, that is x, and y is taken as constant, the derivative of m, that is dm by dl, and Derivative of this term will be 0. Differentiating this equation also with respect to L, we get a raised to the power 4L plus ma square into b square minus c square into dm by dl is equal to 0. Now eliminating dl by dm from these two equations, we get this equation. Now from here, this equation can be written as x upon a square L is equal to y upon m into b square minus c square. Now multiplying these two by L and these two by m and adding, we get Lx plus my upon a square minus c square upon a square. Now this is 1 and this term is shifted in the numerator. So these two terms are further is equal to a square upon a square minus c square. Now from this equation and the equation number 5, we have x square upon a square plus y square upon b square minus c square is equal to this term. So we have obtained the required equation.